Hello everyone. In the previous video we have understood what is Newton's method for system of non-linear equations. In this video we will try to code this in MATLAB. If you haven't checked that video, please go to that video and understand what is Newton's method for system of non-linear equations and try to do the questions manually by yourself before getting to this video. Or you may face some problems understanding the statement of lines in this code. Let us quickly recall what was Newton's method. In Newton's method, we are given system of non-linear equations written as f of x equals to 0, and we firstly find the corresponding Jacobian matrix of the given system, and we generally write it as j of x. The updating rule be j of x n plus 1 into yn is equals to minus of f of x n, where j will be my Jacobian matrix, y will be the difference of x n plus 1 minus xn. To start with Newton's method, the step 1 will be find j of x naught into y naught is equals to minus of f of x naught, where x naught will be my initial points already given in the question. After that, we will find the value of y naught as minus of inverse of Jacobian at the given point x naught into f of x naught. After calculating that, we will have the value of the vector y naught, and from y naught we will find the value of x1 as y naught plus x naught, and in the last step we will update the value of x naught as x1. This is very simplified version of Newton-Raphson method for system of non-linear equations. We will use this updating rule and steps in our MATLAB code directly. There is one more thing that you need to understand is that the value of y here is already the difference between the current and updated value of the vector xn. So the stopping criteria will be the norm of yn should be less than the defined tolerance. Now let us quickly move to the MATLAB code. We will try to make this code as general as possible, and we must need to understand that if we are given a system of nonlinear equations, there can be any number of variables and any number of equations. Firstly, we must know how many variables we are having in the system and how many equations we are having in the system. So for that, we ask the user to input for the number of variables, and equations. Where n underscore VARS will be used as variable to store the entered value of number of variables. After that, we will input the number of equations. Now in this code we have to find the derivative, and we also have to substitute the values of xi's. So for that we have to use symbolic variables, and we will create these symbolic variables dynamically as SYM Now let us understand this statement first. SYMS will be used to create symbolic variables, and the X here will be treated as base name for the symbolic variables. For example, if we have entered 3 variables, then it will be created in the form of x1, x2 and x3, and this will create the array of symbolic variables with dimensions defined by this vector. For example, we have entered the value of the number of variables as 2. Then this will create the output as x1, x2. Why? Because we are taking x as base variable, and this vector will help us to create the elements like this. Now the next part will be to input the equations from the user. In the same way, we will create the symbolic form of the equations. Similarly, if we have entered the number of equations as 2 here, then this will give as the output as F1 and F2, where F will be treated as my base name for the equations. To enter the equations, we use the for loop, which will start from 1 and run till the number of equations we have entered. Now, to take the functions as input from the user, we will use the line of codes as. Now, let us try to understand these statements. We already know that this input function reads the user input from the command window, and whatever is written inside these brackets will be used as the printing statement. Now, this will convert the loop index I to a string which represents the equation numbers, and this S value specifies that the input should be treated as a string. For example, in the loop, when the value of I will be 1, then this will give the output as equation, which will be a printing statement only, and number 2 string will give the output value of I here, which will be 1, and then colon as a printing statement. Note that whatever is in the colons will be treated as a printing statement, and number 2 string will take the value of I from the loop, and when the value of I will be updated as 2, it will give the output as equation 2 colon. Now let us understand the next statement, which says str2 sym, and in the bracket we are taking whatever variable we have used in the previous statement. As we know, whatever we will enter after this will be treated as a string, and this function will help to convert this inputted string into the symbolic expressions, in which we can do some algebraic manipulations. For example, if we have entered the equation number 1 as x1 to the power 2 plus x2 plus 4, in this statement it will be treated as string, but when we will go to this statement, this will convert this equation 1 into the algebraic form rather than the string form. Till now we have number of variables, number of equations, and according to that inputs we have considered the variable names, and after that we have asked the user to enter the equations. Now we need the initial guess, and for initial guess we will again take the user input as x is equals to zeros 1 comma n underscore. Since there will be more than one variable, so to enter each variable we will use a for loop. Starting from 1 till the number of variables xi will be equals to input. So initially we have used a variable x which will be treated as a vector and whose entries are all 0, and then we will use the input statement to enter the initial guess of the variables, and this will help to print the variable number as we have discussed in the previous loop, defining the tolerance as 8 decimal places. The next thing we need is to compute the Jacobian matrix of the given system. For that we will use the variable j to store the value of Jacobian matrix, and will use the inbuilt function Jacobian to calculate the Jacobian matrix with respect to the variables we have already defined. Now all the things that we require to start the Newton's method for system of nonlinear equations are fulfilled. Now we need to start the iterative process. Starting the iterative process with for loop, where I will be initialized as 1 and will go till 100. Firstly, we need to evaluate the function and the Jacobian matrix at the current initial guess. So we will use, let us understand this statement first. Here the double function will help us to convert the result from the symbolic form to the numeric form, and SUBS will be used to substitute the values in symbolic expression, where f is my system of equations and VARs are my collection of all the variables, and this number 2 cell X will convert the numeric array X into cell array of values, and this will ensure that each value in X is substituted correctly into the corresponding variables, that is VARs. So compiling this, SUBS will substitute variables value into symbolic expression. Number 2 cell will convert a numeric array to a cell array for substitution, and double will convert symbolic results into numeric form. Similarly, we can evaluate the Jacobian matrix at the current value of X. For that, we use the line of code in the same way we have used to evaluate F. In the next step, we have to evaluate the value of y, which will be y is equals to minus of inverse of Jacobian value into the evaluated f value. Make sure to use this transpose here, because in this statement, when we will check the dimension of f here, it will be 1 cross 3 and the matrix Jacobian will be 3 cross 3, provided we are entering 3 variables and 3 equations. When we will evaluate J inverse into F, this will be of 3 cross 3 dimension and this will be of 1 cross 3, and this matrix multiplication will not be valid. That's why we have to use transpose here, so that the dimension of them matches. Also, when we have solved a question based on this method, the dimension of f was already in the form of 3 cross 1. If you find this thing difficult to understand, please refer the previous video I have made where I have solved the Newton's method for system of nonlinear equations manually. After finding the value of y, we have to find the updated value of x, which will be as x is equals to x plus y, and again we have to use the transpose here. For checking the stopping criteria, we will directly use if condition, where the norm of y should be less than the tolerance. If this thing is true, then we will break and get out of the loop. Otherwise, this loop will continue until the stopping criteria is satisfied. In the last, we can use a printing statement to print the final solution. Since the solution will be in the form of array, that is why I am not using in the printf statement. Rather than, I will use the printf statement to print the statement on the output window, and will use display function to print the value of the final result. I hope this code is clear to you, and I have tried to explain every statement I am using in this code. Now let us try to input the question we have discussed in the previous video. This was the question we had discussed, and let us try to input this question in the MATLAB code we have created in this video. This will be my output. We will start entering the equations. You can see here that I haven't entered the equations in the form of @x. This is because we have used these set of statements, and this will automatically create the function in symbolic form. Now, similarly, entering all the 3 equations, we will enter the initial guess as given in the question for every variable. After that, the iterative process will start and it will give you the output of every iteration. Please note that in the code I haven't discussed the printing statement of this box. When you will use the code I have provided, it will directly print this statement and it will skip this box. I have used these printing statements to make a better understanding for you so that you can see the updated value of every variable in each iteration. This is the very simple code of Newton's method for system of non-linear equations in minimum possible lines and in very general form. If you wish to modify this code a bit more so that in the command window you can see each and every step including the value of Jacobian, the functions and everything, you can use the other MATLAB code. For that, we will directly move to the screen of MATLAB. On the statement number 12, I have changed the input statement. This is the complete statement you can see. After that, the code is same till the line number 26. After the line number 26, I have used two printing statements. On the line number 27, fprintf will display the statement. The line number 27 and 28 will simply just print the system of equations we are having right now. After that, in line number 31, we will print the corresponding Jacobian matrix. Entering to the loop, line number 36 and 37 will simply print the iteration number and the value of x at that particular iteration. And line number 41 will print the value of f at the given value of x. Similarly, line number 44 will display the value of Jacobian matrix at given value of x. After that, the code is still same, and in the statement number 51, we will print the updated value of x. Rest, every statement of this code is similar to the code I have discussed before. In this, I have just added some extra printing statements so that the output will look better. Let us try to input some another question in this code to see how the output is changed. Firstly, it will ask to enter the number of variables. Let it be 2. Then to enter the number of equations, which is still 2. Now in the next printing statement, we can see that after writing enter equation 1, there is some extra statement printing here. Now entering the first function as, entering the second equation as. In this question, the initial guess was given as 0, 0. So entering the initial guess for variable 1 as 0. And same for the second variable. Now in the output screen, we can see that after entering the initial guess for both the variables, it is printing the function value and its corresponding Jacobian matrix. The iteration 1 will start, which will have the initial value of x as 0, 0, and the value of function will be 8, 8, and the corresponding Jacobian matrix at that value of x will be this. After calculating, the x1 and x2 values will be updated. The same format will repeat for the next iterations. And in the end, when the stopping criteria is satisfied, it will print the final solution, which is given as 0.5 and 2. I hope you have made an understanding of this code. You can use either of the codes I have given you. They both are same codes. In the first code, we have tried to use minimum possible lines in the code, and in the second code, I have added some printing statements so that you can have a better understanding what is going inside the code and what are the corresponding value at each iteration and at every step. Here are some practice questions for you all. Firstly, try to do these questions manually up to 1 or 2 iterations so that you can have a hold over this method, and after that use the MATLAB code I have provided and enter those functions with initial values as 0 and check if you have performed the iterations correctly or not. And if you have found this video useful, then don't forget to share it with your friends. Happy learning!